With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
So the question is, evaluate integration of under root a square plus x square dx. Okay, so the given integration is integration of under root a square plus x square dx. Now let's suppose x is equals to a tan theta. So differentiating both sides with respect to x, we get dx is equals to a. Now differentiation of tan theta is sec square theta d theta. Okay, so we replace dx with a sec square theta d theta and x with a tan theta. So let's say this is equals to I. So our I is equals to integration of under root a square plus a square tan square theta under root. Now in place of dx we write a sec square theta d theta. Now this is equals to integration of under root. We take a square common, so this becomes 1 plus tan square theta. Okay, this is whole under root into a sec square theta d theta. Now we know that 1 plus tan square theta is equals to sec square theta. So this is equals to integration of under root a square sec square theta into a sec square theta d theta. Now under root of a square sec square theta becomes a sec theta. So a sec theta into a sec square theta d theta. So our I is equals to integration of a square sec cube theta d theta. Now a square is constant, so we take it from outside integration. So this is a square integration of, now sec cube theta can be written as sec square theta into sec theta d theta. Now here we use integration by parts. Okay, now in integration by parts we have two functions, first function into second function integration. So this is equals to first function into integration of second minus integral of differentiation of first function into integration of second. Okay, now here we have to assume first function and second function. So let's say this is first function and this is second function. So our I can be written as I is equals to a square. Now we know that first function, which is sec theta. Now integration of second function and integration of sec square theta is sec square theta d theta. We write it as minus of integration d by d theta of first function, which is sec theta, into integration of sec square theta d theta. Okay, this holds d theta. This is equals to a square sec theta tan theta. Okay, minus of integral. Now d by d theta of sec theta is tan theta sec theta. So tan theta sec theta. Now integration of sec square theta is tan theta. So tan theta d theta. Okay, so our I is equals to a square sec theta into tan theta minus of integral sec theta into tan square theta d theta. Now we know that 1 plus tan square theta is equals to sec square theta, or tan square theta is equals to sec square theta minus 1. So our I can be written as I is equals to a square sec theta tan theta minus of integral sec theta. In place of tan theta, tan square theta, we can write sec square theta minus 1. Okay, d theta. Now bracket close. So our I is equals to a square sec theta tan theta minus of integral sec theta d theta. Now minus minus becomes plus, minus integral sec cube theta d theta. Okay, now this can also be written as I is equals to a square sec theta tan theta, okay, plus a square integral sec theta d theta minus a square integral sec cube theta d theta. Now if we see here, our I is equals to integral a square sec cube theta d theta. So this quantity can be written as I. So I is equals to a square sec theta tan theta plus a square integral sec theta d theta minus I. So where minus I go to left hand side, this becomes 2I is equals to a square sec theta tan theta plus a square integration of sec theta d theta. Now we know that integration of sec theta d theta is equals to log of sec theta plus tan theta. Okay, so from here we can write 2I is equals to a square sec theta tan theta plus a square into log sec theta plus tan theta. Okay, so we can write our I is equals to a square by 2. This is sec theta tan theta plus log of sec theta plus tan theta. Okay, now initially we assume that our x is equals to a tan theta. Okay, initially we assume that x is equals to a tan theta, and we also know that 1 plus tan square theta is equals to sec square theta, or sec theta is equals to under root of 1 plus tan square theta. So in place of sec theta we write under root of 1 plus tan square theta. So our I can be written as a square by 2. Now 1 plus tan square theta under root into tan theta plus log of, now in place of sec theta we can write under root of 1 plus tan square theta plus tan theta. Okay, bracket closed. Now in place of tan theta we can write x by a. Okay, from here we can write tan theta is equals to x by a. So I is equals to a square by 2 bracket of, now under root 1 plus, now tan square theta can be written as x square by a square. This is multiplied with x by a plus log of under root 1 plus x square by a square plus x by a. Okay, now on further simplification this is equals to a square by 2 bracket of under root a square plus x square. Now if a square comes out of under root, this becomes a into x by a plus log of under root a square plus x square divided by, this is square, divided by a plus x by a. Okay, now from here we can write I is equals to, now when we multiply a square by 2 inside the bracket, so this can be written as x into under root of a square plus x square. Now here comes a square into a square by 2 plus a square by 2 log of, now if we take LCM here, this becomes x plus under root of a square plus x square divided by a. Now if we see here, a square and a square cancel each other, so our I is equals to x by 2 under root of a square plus x square plus a square by 2 log of x plus under root a square plus x square whole divided by a. Okay, so the value of integral under root x square plus a square is x by 2 under root of a square plus x square plus a square by 2 log of bracket x plus under root a square plus x square by a. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.